Unit 12, Day 4, shifting the sine and cosine curves. As far as graphing goes, the Regents would only ever ask you to do a vertical shift. They might ask you about an equation that shows a horizontal shift, but they have never yet asked you to graph one. So we are just going to concentrate on vertical shifts. Graphing with domain restrictions. So remember, the domain are the x values they ask you to graph. If they say one cycle, best bet is to start with the y-intercept and graph one full cycle and stop. Period is how long it takes to finish a cycle. And the midline pretty much is your vertical shift. It's halfway between the highest and lowest range values. All right, so this is just a little review. We've done this before of graphing a sine curve. So remember, we talk about amplitude, frequency, period, and critical point. So amplitude being the number in front of the trig. Amplitude, by the way, is always positive because it's a distance above and below. The fact that we see a -2 there just says we're going to flip it over. So instead of going up 2, we're going to go down 2 first. So we're going to have a trough and then a hill. So it just flips. Frequency is the number in front of the x. Period is 2 pi divided by that frequency, so 2 pi thirds. And critical points, remember, we're going to take our period and divide it up into 4 equal chunks, and those will provide our hills and troughs and zeros. So it's 2 pi thirds divided by 4. So if you keep change flip, that's times 1/4. So you get 2 pi twelfths, which simplifies to pi over 6. So we are counting by pi over 6. Period was 2 pi thirds. So when we label our x-axis, we're going to count by 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6 is a full pi. Now, since this is 4 pi over 3, I know that goes higher than 1. So I need to stop when I get to something that simplifies to 4 pi over 3. So after 6 pi over 6, I get 7 pi over 6. That does not simplify to 4 thirds. Then I get 8 pi over 6. 8 over 6 does simplify to 4 thirds. So that's as far as I go on the positive axis. Negative axis, I go to -2 pi thirds. Well, that's under a whole pi. So 4 pi over 6 will make 2 pi over 3. So I just got to do 4 of them. -1 pi over 6, -2 pi over 6, -3 pi over 6, -4 pi over 6. That simplifies to -2 thirds. So these are the points, critical points we need to graph. Our amplitude was 2, so I'm going to call this a 2, and I'll call this a -2. And now we're ready to graph. All sine graphs start at the origin, unless they have a vertical shift, which is coming up. And then because the amplitude is negative, has a negative on it, that means we're going to go down to the trough first, then 0, then the hill, then 0. Trough, 0, hill, 0. Connect them with nice curvy lines, or curvies. Then continue the pattern, so we gotta go up, 0, down, 0. And there is our graph. All right, so the shifting. Like I said, they're only going to worry about the vertical as far as what you would have to draw yourself. But we're going to talk about the parts anyway. So you've seen this kind of setup before when you were dealing with the vertex form of a quadratic. As far as the H and K goes, that's your horizontal and your vertical shift, which also is your vertex and that kind of thing. So the absolute value of A is your amplitude, because it's a distance, it's got to be positive. 2 pi divided by the b is the number in front of your x, so that's your frequency. 2 pi divided by frequency is your period. Your H is your horizontal shift, also in trig known as a phase shift. And the K is your vertical shift, which would be equivalent to your midline. Your midline is the average halfway between the highest and the lowest. So it's actually supposed to be max plus min divided by 2. It's the average of the highest and the lowest, and it's a horizontal line, so it's going to be a y equals line. All right, graph one cycle of y equals negative sine x plus 2. You probably won't have to do this for more than 1 or 2 graphs, but I am going to continue to do it just to help out anyway. What I do is I start off by graphing the trig graph without the vertical shift first. So I'm going to graph y equals negative sine x in blue. So my amplitude is 1. Just don't forget it's negative. My frequency is 1. So my period is 2 pi divided by 1 is 2 pi. And my critical points then are 2 pi divided by 4. So that becomes pi halves. I haven't graphed a regular graph in a long time. So the period is 2 pi. Okay, the range you might want to answer after we're done because it's for the question, not the one I'm doing. All right, so I am graphing this one right here, the one without the vertical shift. So my amplitude is 1. It says graph one cycle, so I'm just going to graph the positive cycle. Sine graphs start at 0. We're counting by pi halves. All right, so the amplitude is 1, but it was a negative in the equation, so that means I'm going down to the trough first, then back to 0, up to 1, back down to 0. So it's a flipped over sine curve. Okay, so that's the blue one. But what I'm going to do now, okay, there's my one cycle. What I'm going to do now, it's a vertical shift of 2. So I'm going to take each one of those points and I'm going to shift it up a value of 2, which had I been thinking, I would have numbered my graph a little different, because here's 2, here's 3. So I got to go as high as 3, which means I should have only used one block instead of skipping, but that's all right. We'll fudge it. All right, so I'm going to take each one of the points I plotted and move it up 2, like the transformation says. So up 2, negative 1 goes to 1, 0 goes to 2, 1 goes to 3, and 0 goes to 2. So then I redraw it. And I am allowed to do this on the regions as long as I label my graphs. Okay, so the red one is the one that they wanted me to draw. I find it easier to draw the regular trig and then just move all the points up instead of having to think about it and misplacing something. That's just me. Well, there you go. So the range of the red graph, it goes as low as 1 and goes as high as 3. Well, if your amplitude is 1, then that means your function goes from negative 1 to positive 1. And that vertical shift says you add 2. So if I add 2 to both of them, because I'm going up, negative 1 plus 2 is 1, which is the first number for my range, and 1 plus 2 is 3, which is the second number. So I can actually find my range without graphing. I take the amplitude and add 2 or subtract whatever the vertical shift is from both numbers, and that's my range. So my midline on the original graph would have been y equals 0. But then if I draw the midline on the red graph, it's y equals 2. That vertical shift becomes your midline, always. All right, so another way to think about it is amplitude is how high above and below the midline you go. So if my midline's at 2 and my amplitude's 1, I'll go up 1 to 3 or down 1 to 1. So there's another way to find your range without graphing. All right, number 2. Graph one cycle of this cosine graph. All right, I'm going to save the shift for later. So I am first going to graph y equals negative 2 cosine x. And I'm not going to make the same mistake I did last time. I'm counting by ones on the y-axis. All right, Now, let's fill out some of this stuff before we graph. We just said on the last problem that your vertical shift is your midline. So my midline is going to be y equals -3. Your range are your y values. Amplitude tells you how high above and below the midline you are going to be. So if my midline is -3 and my amplitude is 2, then I go 2 above, so -3 plus 2 would be -1, and I go 3 below. -3 minus 2 would be -5. So my range, when I'm done graphing, should be -5 to -1. Okay, let's see how that works. Period, because I don't have a frequency listed there, is going to be your standard 2 pi. So amplitude, again, I'm going to do it without the shift first. Amplitude's 2. Frequency, the number in front of the x is 1. Period is 2 pi divided by 1, which is 2 pi. So my critical points are 2 pi divided by 4, which makes pi halves. All right, so pi halves, pi, 3 pi halves, 2 pi. Okay, one cycle only has 4 points, so I know I can skip spaces on the x-axis. All right, so cosine graphs usually start in the air, but since the amplitude's negative, it's going to start down below. So remember, I'm still graphing the one without the vertical shift. So I'm going to start at -2, go to 0, +2, 0, -2. That way my cosine graph has gotten flipped over. Remember, it's supposed to be a cursive V type thing. All right, so this is y equals -2 cosine x. Now my vertical shift says go down 3. So now that I got those points, I'm just going to go down 3. 1, 2, we're fudging it again. There's the -5. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2 off the graph. And there's your vertical shift. And if you look at the range, you got -5 for your lowest and -1 for your highest, which we figured out before we even graphed it. Okay, number 3. Graph one cycle. So let's see, let's figure stuff out. My midline will be y equals 1 because my vertical shift is 1. My amplitude is 2, so that means I'm going to go 2 above and below my midline. So 2 points below 1 would be -1, and 2 points above 1 would be 3. 1 plus 2 is 3. So my range should be that. Frequency is 3. So my period is 2 pi divided by 3. Okay. And now I'm going to let you in on a little secret. So this is going to help the people who are actually watching these videos. You don't actually have to label every critical point. Now, if they give you the domain that they want you to graph, yeah, you kind of do because you need to know where to stop. But if they just graph one cycle, all you need to do is label the last critical point, which happens to be your period. So what I'm talking about is we know that there are 4 critical points. So there's 1, 2, 3, 4, and I know the last one is my period. So 2 pi over 3. And if that's all you labeled on the x-axis on a Regents, you would still get full credit. All right, so I'm going to do these 1, 2, 3, and 4. And -1, -2, -3, close enough. All right, so cosine curve starts in the air, and I'm just graphing without the vertical shift. So y equals 2 cosine 3x is all I'm graphing right now. So my amplitude is 2, I start at 2. Then 0, and -2, and 0, and 2. So I'm graphing without the shift first. I just find it easier. And now all I have to do is take each one of those points and move them up 1. So there's 1, up 1, up 1, up 1, up 1. And see how quickly that goes? 2, 2 cosine 3x plus 1. But this little label trick, if it says graph one cycle, you can get away with that all the time. If they tell you the domain, yeah, you better find the critical points. So all I gotta do is fill this in. The period was 2 pi over 3, and that problem is done. All right, number 4, midline. Y equals -1 because our vertical shift is down 1. The range, let's see, the amplitude is a half. So that means I'm going to go a half a step above -1, which is -1/2. And I'm going to go a half a step below -1, which is -1.5. Decimals, fractions, doesn't matter. Okay, my frequency is the 2 in front of the x. So my period is 2 pi divided by 2, which means the period is pi. So I can fill all that stuff in before I even make the graph. Now it said graph one cycle. That means I can get away with the shortcut. 1, 2, 3, 4. Label the last 1 year period, which is pi. All right, so I'm dealing with halves. So I'm going to say that this is a half, this is 1, this is 1.5, and this is 2. And I'm going to label that 0.5. -0.5, -1, -1.5. All right, so I am now graphing the trig function without the vertical shift. So sines always start at 0. Half is the amplitude, 0, -half, 0. Connect the dots. So this is y equals half sine x. Oops, 2x. And now I'm going to vertical shift 1. Now, each block for me counts as a half, so I have to move everybody down 2 blocks because that moves it down a value of 1. So the 0 turns into -1, positive half turns into -half, so I'm moving everybody 2 blocks is basically what it is, which is a value of 1. Connect the dots. Y equals 1/2 sine 2x minus 1. And we're good to go. Just make sure you label them when you do it for homework and Regents exams. All right, we have another one. Okay, our vertical shift is -2, so the midline is y equals -2. My amplitude is the 2 in front of the cosine, so that means I'm going 2 above and 2 below the -2. Well, if I go 2 below -2, -2 minus 2 makes -4 for my lowest. And if I go 2 above, -2 plus 2 makes 0 for my highest. All right, frequency is what's in front of the x, which is pi halves. That's a weird one. Period is 2 pi divided by the frequency, which is pi halves. So keep it, change it, flip it. Keep it, change it to multiply, flip it over. The pi's will cross off, and we get a period of 4. Again, it says graph one cycle. So 1, 2, 3, 4, and put the period on the last one. So obviously we're counting by ones. 1, 2, 3, 4. All right, so again, I am graphing without the vertical shift first. Cosine graphs start in the air. My amplitude is 2, so I'm starting at 2, 0, -2, 0, 2. Curvy. Label it. I'm going to be lazy this time and label it A. I'm going to put a B next to the one with the shift. The shift says shift down 2. So down 2 values, puts that at a 0, puts that at -2, -4, -2, and 0, which there's our range, -4 to 0. Connect the dots, put a B, and don't forget to fill in the period, which we said was 4. All right, that's the end of the examples for day 4. Give the homework a try. Good luck.